Hello everybody and welcome back to LangChain Zero to Hero, an unofficial tutorial series teaching you everything you need to know about the LangChain tech stack to get started with your own generative AI projects. In the last episode we used LangServe to create a simple REST API, and we tested the API using the LangServe playground. In today's episode we will explore LangSmith and set up the proper monitoring and logging for our API, upgrade our PyTest to use LangSmith datasets, and check out the prompt hub to store a prompt in the cloud and learn prompt engineering techniques from others. Now before we dive in, remember that you can find the prerequisite code for this project on GitHub. Simply head to the releases page. So from the main page of the LangChain Zero to Hero project, head to the releases page, click episode 2, LangSmith, and you should be able to download all the necessary files from here. Now, another important prerequisite is to go into the link in the description and sign up for a LangSmith account at smith.langchain.com. You may have to wait a little while for the waitlist and to get approved, but once you have, you'll be able to proceed with this tutorial. So I'll wait, just go ahead and do that. I assume that you've gotten it done within those 5 seconds. If not, feel free to pause and come back to this video once you have. Diving in, once you have access to LangSmith, the very first page that you should be presented with is this home page. You can see that LangSmith offers a whole bunch of features, including something called projects, datasets and testing, annotation queues, and the hub. Okay, this is a lot to go through, and in one video, so we're going to make it brief but concise. The very first thing that we need to do is integrate LangSmith with our LangChain project, which sounds complicated, right? Adding logging, connecting it to a web platform. It's not. It's so easy and you're going to love it. The first thing that you're going to need to do is click onto the API keys button in the bottom left. Once you've done so, you'll then be presented with a page very similar to this. You'll want to click Create API Key, as I have done in the past, and copy the key somewhere safe. Most importantly, you're going to want to copy it into your Visual Studio Code application, more specifically your env.rc file. As you can see, what I've done today is update the env.rc file, or the example file, with 4 additional environment variables. Now you don't have to type this all out manually. There will be another link in the description to the LangSmith quick start tutorial, so you'll be able to find a copy paste of all of these environment variables very easily. But running through very quickly, the LangChain tracing and LangChain endpoint environment variables are hard coded. They're set to the exact same values. However, they might be updated in the future, or if you're using LangSmith, not using the LangChain online portal, perhaps you're hosting it yourself. But what we need to care about today is the LangChain API key, which should be the value that you've just created, and the LangChain project. Although actually, if you want, you can just replace this with either an empty value or default, since we'll just be working with the default project for today. Now, once you've updated this, you want to head into your terminal. Make sure that your terminal has access to those environment variables, such as using the dir-env-allow command, and then we just want to run our PyTest. It's as simple as that. Now what will happen is our PyTest will run, and then when it tries to make a chain call or an LLM call, all of these things are going to be logged into the default project, or whichever project name you chose, on LangSmith. So let's wait a second. The test has passed and completed, and if we head back into LangSmith, you'll be able to see that our project page, we now have a project. If we click in, it's named default, just as we expected, and lo and behold, we have a trace. Now a trace is essentially the run of a chain. It can be a little more complicated than that sometimes, but for today, that's as complicated as it gets. What you're going to want to do is not lose your voice for one, but you'll also then want to click onto the runnable sequence. And then we can see what has just been executed. Now the runnable sequence is essentially our chain. It contains our chat prompt template and our chat OpenAI LLM. If we look into the prompt, you can see that it's the exact same prompt with the system message and the human message that we looked at in episode 0 and 1. And then chat API, you can see that we are sending the two chat messages as input to the OpenAI LLM, and what's being responded with is an AI message. As you'll remember, very similar to what we were seeing in the LangSmith playground during episode 1. Going to the runnable sequence as a whole, you can see the input is our key value input, and the output is the actual JSON, or YAML, but we can switch to JSON, of the AI message. Beyond this, you can also click into the LLM calls in order to actually see individual calls being made to the OpenAI LLM, or whichever your provider is. This can be useful for looking at what is actually costing you money versus what is just simple internal traces of your API. And you also go to the monitoring tab. You'll be able to deep dive into each of these graphs, and their uses should be fairly obvious. The most important graph, in my opinion, is the latency, which indicates how slow your project is, and the total tokens being used, which indicates how much the API is costing you to run, which can be very expensive. The latest OpenAI GPT-4 model, GPT-4 Turbo, has a context window of 128,000 tokens. What this means is that it's about 300 pages of text. That's a lot of text, and that's a lot of money, given that even though we are talking about tenths of a cent less in order to run 1,000 tokens, if you're running an API that routinely runs over 100,000 tokens, that's going to be expensive. But what we can then also skip over most of this, since we only have a small API, we don't need to be worrying too much about performance. Now, let's dive into datasets and testing. Now, when we go to our datasets and testing, we have no datasets yet because we've not created one. So, moving my camera, what you should now be able to see is in the top right, two buttons, new test run and new dataset. Let's start with a new dataset. We can name this Pirate Dataset, since we're testing our pirate chain. And we have three different types of dataset. The first is key value, the second is chat, and the third is LLM. You can experiment with each of these values depending on the type of chain that you're working with, but today we'll be using key value. Now if we create one, we'll see that we now need some examples to populate our dataset. If we click Add Example, we're now presented with the opportunity to add some examples. So let's add the input that we're expecting, text, and then stealing from our test chain. Hi there, do you have any gold for me? But you can also put whatever you like. And then as the output, now remember that I was showing you that the output of this of our chain, as we know, is going to be a AI message. However, we're working with key values, so what we're going to want is a JSON schema for our AI message. This is the input and the output that we should be expecting. So we click Submit to add this as a new example to our pirate dataset. Now that we have an example, let's have a look at tests. We've not run any tests yet. How can we run tests on our examples? Let's click New Test Run, and we're presented with an awful lot of information. Now, on the left, we can see that we have the opportunity to select some evaluators. The concept behind evaluators is instead of having humans review tests, which can be very complicated once you get up to hundreds of tests running, particularly if you're running tests often, You can instead have an LLM perform some naive evaluation in order to compare the actual output of an LLM with the expected output. This is obviously quite difficult to do programmatically, since an LLM can vary its output. When we're making calls to the chat OpenAI, we're not specifying the temperature, so it will be some default value, probably not 0, meaning that there's a slight degree of randomness within the output. It's not going to be the exact same output every single time, which is good for us because we want a conversational assistant who doesn't repeat just the same old boring voice lines, but it is difficult for us to actually test to make sure that it's still responding in a way that we desire. Moving on, we'll return to evaluators in another episode, since it deserves an entire episode to deep dive into this concept. We can ignore a lot of the setup since we've already done this, and we can actually ignore a lot of the example code that it wants us to add. You could take this entire script and run it as a .py file, and it would work just fine, but you see that we're actually ending up creating another prompt in a chain, which isn't useful because we want to test our own prompt in chain, not the one given to us by LangChain. So instead, we just want to import LangSmith, copy this single line, head into our test file, and add it in. And then heading back, we also want to copy lines 17 through to 24. And again, heading back to Visual Studio Code, we can actually replace the contents of our test chain with this copied code. What does this copied code do? First of all, we connect to LangSmith and create a client object, and then run the method of run on dataset from our client. What this does, as it might be implied, it runs our chain that we specify on the dataset that we specify. And then we have a project name. We can also have the verbosity, which is just some information, how much information we're given, and the concurrency, which can talk about how many chains we're trying to run concurrently within PyTest. We can just leave these identical. What we're going to want to do, however, is catch a issue that will occur in the future. Since we're setting project name to a single string, we can run this once. However, if we then try to run it in the future, it will crash, and the reason being that our project name needs to update every time that we run our tests. So this is designed to be run once, but not multiple times. In order to account for this, we're just going to need a little code snippet. Now let's look at this snippet. We import the datetime module, and then we set a variable a, which is basically just going to get us the year, month, and day as integers. We can also get other information out of this, and actually it might be useful for us, seeing as we may be running multiple tests a day, %h, %m, and %s. And we're going to want to add these as well. And if we just double check the method documentation, you can see that we're using all of the correct format. So now what we'll end up with is a big old integer indicating the year, month, day, hour, minute, second that we executed our test, which should be fairly unique since we won't be running tests more often than that. We'll also want to replace this name with just something generic like test, or perhaps pirate dataset test to tie it. Now, every time that we run our test, it will then create a new project name, and then everything will work totally fine. If you want to understand why this doesn't work, try setting a project name which is the same string and running it multiple times. You'll quickly run into the error that I'm anticipating here. Now, going back into our terminal, let's clear things up and run PyTest once more to see what happens. Once our test has finished collecting and has connected to LangSmith in order to download some of the tests that we'll be performing, you'll see a nice little, there we are, perfect. You'll see that we are running evaluation results for the project pirate dataset test, and then this big old string, which will be nice and unique, so we won't run into any issues. There's a link, but we don't need that, seeing as we'll be checking out the LangSmith platform once our tests are complete. We run through all one of our test examples in our dataset, and we pass. What we then want to do is head back on over, back out of our new test run, and you'll see that we have our test created just here. If we click on it, you can see we have a test. And then we run that test, or click into it, and see that we have input, which is the expected string that we passed into our LLM, and we have an output, which is the generated string. And then beneath it is the reference output, which is what we were expecting. This once again highlights the difficulty with trying to evaluate LLMs and why human evaluation is still one of the most prevalent methods of evaluating. If we check out the reference output, we expected something along the lines of, "Ahoy there matey, I'm a humble assistant, I don't have gold, but I can help you with any other questions. What kind of assistance do you need?" In a pirate tone, of course. But what we actually got out was, my hearty, or my matey, I'm sorry to say I don't have any gold, but I can still lend you a hand. What you need help with, my hearty. These are semantically identical, and this output is very acceptable for our pirate application. However, it's not the same as our reference, which means that even an LLM evaluating these two outputs may get a little bit confused sometimes. Again, we'll dive into LLM evaluation in another episode. But for now, we want to click into the top right and click Annotate Run, so that we can provide some feedback about what we've just ran through. As we can say, currently the default feedback, we can add new feedback if we like, but we aren't going to. We're just going to rate this on correctness, which is a score of 0 or 1. We're going to say that it's correct and rate it 1. If we close the annotation, we can then click into feedback and see that this run has had this feedback associated with it. This can then be useful for in the future if we wanted to add this input and this output to the dataset to improve our variety of expected outputs. We can click Add to Dataset with this text and this output, select our pirate dataset, and submit. If we now back out of our trace and back out of the project into the pirate dataset and examples, you can see now we have 2 examples for the same input, expecting the same kind of output. Obviously, it might be more valuable to have different types of input, but given the fact that it can also be useful to have the same input, testing multiple times to see what can the variety of outputs that can be achieved. It can depend wildly on your use case. Now, let's go into another part of the LangSmith ecosystem, the LangChain Prompt Hub. Now, we're immediately presented with dozens of prompts. What are these prompts? These prompts can be passed into chains, sometimes very specific chains, but in a lot of cases, just chat prompt template chains to perform certain tasks. Now, what we're going to look for is, let's see if we can search. Yes, we can. Here we are. So this was something that I selected beforehand, the personality chatbot prompt. This allows us to create a bot personality and a user personality. So we already have our bot personality, but what if we experimented with a user? Again, in the top right, we can click Try It in order to open up the prompt playground. Now, the prompt playground is very fun. We can customize the system prompt. So in this case, we don't speak Vietnamese, so it's just going to be a helpful assistant. Actually, a helpful pirate assistant. I'm forgetting myself. We don't want to give a personality here. We want to enter the personality on the right in the inputs. Reading through the system prompt, you are a helpful assistant with given personalities. Help the user answer the question or chat with them about anything they want. Below are the personalities of your personality Below are descriptions of your personality traits. Talk to users according to those traits. And then we had the bot personality. So we say, you are a pirate. And then the user personality, I am your captain. We are going to be the captain of this pirate. And then the current conversation history, which is going to have a space. We have to have some sort of value, but we aren't actually going to have any history up to this point. Actually, because we're not going to work with any history, let's just delete it entirely, and you'll see that it updates. So no, there's no longer the expected input. And then we have the human input. And similarly, we could rename it to whatever we want, such as message. Say, hi. How are you? Truly inspired, I know. Now, another thing that you're going to want to remember before you can click start in that bottom right corner is to go to the top right corner again, secrets and API keys, and make sure your open API key has been copy pasted into the website. As you can see, it's only stored locally in your browser and used to form API requests to, in this case, ChatGPT, or GPT 3.5 Turbo. So it's entirely safe to use. But this will then allow us to click start and have an output generated. And again, it is identified that it's a pirate, and it identifies that we are the captain as we told it, and it says and we say how are you? It says it's ready for a seafaring adventure. This is all great, but what we actually want is to bring our own fantastic pirate prompt that we totally didn't steal from the LangChain default template, and we want to bring it into the LangChain prompt hub for everybody else to enjoy. Now, actually, in the top right, click the plus button to create a new prompt. We'll want to set our prompt name to best pirate ever, because truly we have perfected prompt engineering when it comes to this chain and this assistant. Now you can fill in a description, you can fill in a readme, you can fill in use cases, for instance a chatbot, a language, we're going to talk in English. You set visibility, and in the future you'll be able to set things like licenses. We're going to leave a lot of this empty and for you to explore yourself. Once we're done, click save and we're transported to our page. But there's nothing here because we've not yet actually created a template. Now we want a chat prompt, seeing as we are working with chat prompts. And what we're going to want to go to is our Visual Studio Code, our chain.py, and we're going to want to take the information from the chat prompt template that we're creating. In this case, the system message telling us that we are a helpful assistant who speaks like a pirate. And the expected input of text from the for the human, wrapped in curly braces to indicate an input. And another great thing about the prompt playground is that we can run this test ourselves. So we can say, hi, where is the gold? That great old question. Run start again. And say that be seeking the hidden treasure, etc, etc, etc. In this case, it's actually quite wordy. This could be because our LLM is working with the GPT 3.5 Turbo model, whilst it's unclear if we're working with the 3.5 Turbo model in our API. We may just be connecting to regular old GPT 3.5. This also highlights that in between models, it can be very different responses for identical prompts. But we're quite happy with this, so let's commit. Committing it to the best pirate ever prompt. We then can go back to our best pirate ever page and see that we have created a public prompt with our chat prompt template. Now, you can see this use object in LangChain. This is how we can take our prompt rather, from the LangChain prompt hub and actually use it in our application. So, copying that code snippet into your chain.py file and making sure that you stay up on the right scene, you'll be able to pull down your prompt into your local file. Now, tidying things up, making sure the variables are named as expected, you might be wondering, what are some of the advantages of doing it this way? Well, developing upon LangSmith and with the prompt hub makes it a lot more convenient to work on these sort of prompts and to test them easily. But it can also be a way to reuse prompts or to quickly sub in different prompts that you think might be useful, maybe made by other people. Now, let's go back into our terminal and run again to make sure everything is working. But before we do, we're going to want to type in poetry add LangChain hub, if I can spell it correctly. Now, why do we need to do this? LangSmith comes included within LangChain. However, LangChain hub does not. It's an optional dependency because you're not always going to be using it, even if you are using LangSmith. However, installing it takes a couple of seconds, so once you've typed that in and it's finished installing, we can run our tests. There we go. Now, what you need to be remembering is we have created a dynamic name for our tests, so that means that the timestamp attached to the end of the test, here we are, is going to be a different timestamp and therefore a different string name and therefore a different project name, unique from the project we ran previously, which is important because of the unique requirement for project names in LangSmith. And also we ran 2 tests this time as opposed to 1, since we added the previous test result as a new example within our dataset. Going back into LangSmith and returning to our datasets and testing, let's go back into our pirate dataset and look at this test that we ran most recently. Here we have 2 successful tests ran with the correct chat prompt template, and you wouldn't even be able to tell that we pulled this down from Prompt Hub as opposed to working just purely within Python. And we have 2 separate responses with 2 separate expected responses. Okay, that wraps up everything that we're going to be covering about LangSmith today. Thank you very much for watching, and in the next video we'll be diving into some other features of LangSmith and also advancing the very simple chain that we've got into something a little bit more interesting, perhaps with retrieval augmented generation. Once again, thank you very much for watching, and I'll see you in the next episode. Goodbye.